Hello everyone, we are Isa, Nina, Lydia, and Sharon. Do you want to understand what this cool thing is? Let us reveal the secret behind it. What is the water rocket? First one is a type of model rocket. Second is uses water and pressurized air as propellant. And third is uses aerodynamics.
Then I will introduce aerodynamic. Aerodynamic is the study of how air affects moving objects. When something moves through the air, it faces two main forces, drag and lift. Drag is the air pushing against the object, which slows it down. Lift is an upward force that help things like airplanes. For example, in water rocket, the fins help keep the rocket fly straight, which is related to lift. At the same time, the rocket faces drag, which slows it down. A small shape reduces drag, while a rough shape increases it.
Now, I'm going to talk about Newton's law of motion. First, we have Newton's first law, also called as the law of inertia. It means that if no force is applied, an object will stay at rest or keep moving at the same speed in a straight line. For example, when you are in a car and the driver suddenly hits a brake, you feel like you are moving forward. That's inertia. Next is Newton's second law, which is written as F equals ma. This means that force equals mass times acceleration. In simple terms, if you keep a soccer ball with more force, it will speed up more. Now, let's talk about Newton's third law of motion. It is also called the law of action and reaction. It states that for every action, there is an equal and opposite reaction. In simple terms, if you push on something, it pushes it back with the same force. And applied to the water rocket, when water is spread out backward, the rocket is pushed forward or upward.
Next, let's talk about projectile motion. Projectile motion is how things move when we throw or launch them. Gravity pulls them down, and their path looks like a curve called a parabola. There are two directions in projectile motion. 1. Horizontal direction. The object moves forward at a steady speed. 2. Vertical direction. The object falls down faster because of gravity. This explains how things like a ball or a rocket move when we throw them. Our goal is to make the water rocket fly farther. This is our dependent variable, which we measure. We change the independent variable, which is the shape of the fins. We choose triangle-shaped fins. To keep the experiment fair, we keep other things the same. 1. The fin area is 63 square centimeters. 2. There are 4 fins. 3. The rocket bottle is made of plastic.
And the content of rocket is water. The volume of water is 323 milliliters, and the length of the water rocket is 33.5 centimeters. Our launch angle is 40 degrees. Pressure is 5 kilograms per square centimeter.
What are materials to build a water rocket? We need launch system, nose cone, 2 soda bottles, tape, plastic bag, pump, utility knife and scissors. And next one is cardboard. Step to build a water rocket. Step 1. Cut out the middle 1/3 of the bottle. Step 2. Connect the bottle from the first step to another complete bottle. Step 3. Use count board to cut 4 triangular fins of the same size. Step 4. Stick the 4 fins cut out vertically on the bottle. Step 5. Tape the cone to the end of the bottle.
Fins help rockets fly better by providing stability, reducing drag, and improving guidance. They keep the rocket straight, prevent flipping, and help it soar higher by cutting air resistance. Angle fins also create spin, enhancing stability. In short, fins are key to smooth and controlled flight.
How do triangle fins reduce drag? The first one, reduce flow separation. The smooth edges of triangle fins guide the airflow and reducing sudden changes. The pointy rear end prevent airflow from breaking off, which reduce turbulence and drag.
Next, major reason is vortex formation. Wide or rectangular fins create vortices at the edge, which increases drag and slows down the rocket. On the other hand, triangular fins guide the airflow smoothly toward the back. This helps reduce vortices and make the flight more efficient. So, by using triangular fins, we can improve aerodynamics and help the rocket travel farther with less resistance. We will compare how different blade shapes affect the airflow. First of all, a rectangle fin makes the airflow separate easily, creating big turbulence which affect the flight height.
And the trapezoid fins help the airflow gather slowly, reducing the impact of vortices, making it suitable for fast flight.
Then, a triangle fin directs the airflow smoothly to the rear, reducing drag and forces, which is good for long-distance flight.
没事的。
Thank you for your listening and hope you